Here is the knowledge given to me by a mythical creature called solidity documentation. Everyone knows about optimization, but most people think it just makes compilation slower and kinda sucks, I guess. But let's explore a bit more about what it actually does, using the example of common sub-expression eliminator. Sounds hella smart if you mention it in a casual conversation with your non-technical friends. So, if you're here just for that, feel free to leave, and my fellow nerds can stay. In simple words, it's a compiler process that hates repeating statements and tries not to do the same thing twice because it's too lazy to repeat operations. For example, if you're writing 2 plus 2 15 times in your code because you don't know what dry is, the compiler can fix it. It precalculates 2 plus 2, stores it, and replaces every place where you used it, so it won't need to recalculate the same thing over and over. Here is a more practical example. Check out this code. It's super simple. Just hashes a value and returns a result. Now let's take a look at the bytes compiled without optimization and with optimization. Looks kinda different, right? There are fewer slock overall, and there is only one hash opcode. This happens because Solidity understands that 100 will be always 100, even if aliens invade our planet. So it pre-stores the hash directly and just pulls it from memory every time the function is called, instead of recalculating it each time. By the way, a little fun fact at the end. Do you see these two random hashes? Did you know these are just encoded words? The first one is SOLC, and the second one is IPFX-X, and they are just additional metadata about the compiled code. Cool, right?